So in the previous lecture, we actually finished this one slide, the general introduction about the negatron emission, or you can call it the beta decay or the beta negative. And we have already discussed how the neutron are converted into the proton. There is an increase in one proton, or maybe there is the decrease in the one neutron. So that is happening with the negatron emission. And by using these equations, you can calculate the energy changes. So moving towards the phenomena which is associated with the negatron emission, that is called the Bremsstrahlung. So this is actually the German term, and it is used for breaking or slowing down the process. So this process actually is associated with the negatron emission. So whenever there is the negatron emission, there is the possibility of the Bremsstrahlung effect, or that is the breaking or the slowing down the process. So actually what is happening with the negatron emission. So look at any one of the image over here. This is the nucleus, or it is presented over here. This is a parent converted into the daughter with the increase of one atomic number and the emission of the electron or the beta negative. So these are the same as we explained before, having the same mass and the same charge, but they have some difference with the while the electron is emitted or the neutron is emitted with the parent, and that we will discuss right now after this phenomena. So it is also emitting the antineutrino. So actually what is happening when the neutron is emitted, this is the nucleus. Actually neutron is coming out of this because one proton neutron is converted into the proton. So all process is happening inside the nucleus, and when there is a emission of the neutron, so when the electron or the beta negative or the neutron is coming out of the nucleus, so you have a look on this, it is surrounded by the extranuclear particles, and these are the electrons. So that means electron beta particle has to be emitted from the nucleus by crossing all these boundaries, which is surrounded by the electrons. So what is happening over here? This nucleus is having a positive charge, and the negatron emitting, which is emitting out of the nucleus, is having a negative charge. So positive charge and negative charge, of course, they must have some sort of the attraction to each other. So what is happening? This is the general phenomena I have just shown over here. Let's suppose if any of the electron is moving towards the any of the atom or the nuclide, and what is happening, instead of going straight, it is little bit declined. That means its speed is deaccelerated in the vicinity of the positive Coulombic field of the nucleus, because this nucleus is having the positive charges. So if the electron is passing nearby this nucleus, and this is going to be attracted by the nucleus because of having the opposite charges. So this speed is deaccelerated. So electron, the energetics electron get deaccelerated. So with this one, that means it may lose some of its energy, and that energy is actually due to this deacceleration is called the X-rays. So energy associated with the this one process, that is called the production of the X-rays, and this phenomena is called the Bremsstrahlung, because this X-ray is generally generated or it is produced just due to the deacceleration of the electron which is coming out of the nucleus, and this is only happening due to the attraction of this negative charge with the positive charge. So simply again, if the negatron which is coming out, this is the extra electron, just as an example I have shown over here, just to understand the process, how this is going to be de-accelerated because this has to be passed like in this way, in the straight way, but it is little bit decline, and this decline is due to the lower of the energy, and this energy is released, which is called the X-ray, and this process is called the Bremsstrahlung process or the effect. So similarly, if the electron or the negatron is coming out of the nucleus, of course, instead of going straight, it is going to be attracted by the positive charge because both are having the opposite charges. So in a similar way, this is going to be deaccelerated and it will be the loss of the energy. That loss will be the X-rays. So total energy will remain the same. So that loss is coming out of the X-ray. So again, there are two type of the X-rays. One may be the high energy Bremsstrahlung X-ray and one may be the low energy Bremsstrahlung X-ray. It depends on the nature of the nucleus. Some nucleus having the more protons as compared to the other ones. So that means this deceleration may be different depending on the charge on the nucleus. So what is happening over here? That means it is simple to understand. This is the Planck's law. E is equal to h mu. Mu is the frequency. H is the Planck constant. E is the energy. So when you place the value of the mu is equal to c over lambda. So look at the relationship between the energy and the wavelength. When wavelength is small, energy will be high, and when this is large, energy will be low. That means both energy and wavelength are inversely proportional to each other. So now look at this diagram, how you can call them. This is the low energy X-ray or which one is the high energy X-ray. So look at the low energy Bremsstrahlung X-ray. This is, and this is the high energy. So look at the wavelength. This is the length of the wavelength between two crust or the trough over here. From here to here, this is the one wavelength. Again, this is the half, this is the one wavelength, one complete, that is the one wavelength over here. So the length of this wavelength is large as compared to the length of this wavelength. Look at it. This is the small wavelength and this is the large wavelength. So if wavelength is large, then energy will be low. So that's why, according to the Planck's phenomena, if it is having a large wavelength, then energy will be low. And if it is having low wavelength, it must have a high energy X-ray. So how it would be high energy or the low energy, depending on how much it is the deceleration towards the nucleus, and this depends on the how much the nuclide is having the positive charge. So in conclusion, must remember that this negatron emission have the alternative phenomena, and this is called the Bremsstrahlung effect, and this is going to produce some of the X-rays, and it may be the high energy or the low energy X-ray. Now coming to the difference between the negatron and the electron. So again, if you look at the both have the same charge, and of course the other similarity is both are having the same mass. So what is actually the difference between the electron and the negatron? If electron is coming out and if negatron is coming out, then what would be the actually the changes which are happening with the parent as compared to the daughter? So this electron, whenever all these are the electrons which are shown over here, first two, then these are the 1, 2, 3, 4, 5, 6, and similarly, these are going to be increased depending on the shell, K, L, M, N, and shell. These are the shells. So if this electron is removed, again, the first difference is this is the extra nuclear part. This is the extra nuclear property of the nuclide. It is coming out in the one of the KLMN shell, which is the extra nuclear part, but this negatron is having the nucleus property. It is coming out of the nucleus. So this is the one difference. As we have discussed, there are the two similarity, charge and the mass are same. These are two similarities. So the one difference is this is the extranuclear part, but neutron is the nucleus part. And one of the more important, because when electron is emitted, it is the positive charge on the any of the nuclide, and when the neutron is emitted, because look at one neutron is converted into proton, that means proton are increased, so there is also increase is the positive charge while emitting the negatron. So what is the actually the now the difference between the negatron and the electron? So look at, this is the main difference, one of the major difference. With the emission of the negatron, there is increase in one proton, while with the emission of the electron, there is no increase or decrease in the proton. And the second difference is, look at the mass, what is happening with the increase of one proton, there is increase in one atomic number. That means the nuclide would not be the same as you have the daughter in case of the neutron emission. But with the electron emission, it will remain the same. If one electron is removed from the sodium, it is sodium plus, that will remain the sodium nuclide. There is just the charge with the removal of the electron. While when neutron is emitted, it should not be the sodium, or it should not be the same nuclide, because there is increase in one atomic number. Now the atomic number will increase. So this is the main difference between the neutron and the electron. One of is the extranuclear property, one is the nuclear property. So our focus is to discuss the nuclear properties of the nucleus behavior, what is happening inside the nucleus. But it is important to also know that actually what would be the difference between all these the particles, electron or the neutron. So just first, I'm going to do some exercise over here, and then I will move to the next topic, the other radioactive decay. So here, this is the example as we have discussed in the previous alpha particles. In a similar way, maybe I may skip this one, or I may skip this one, or I may skip this one. And you have to look on what actually the process is going on. And this is the same as I have said. Maybe you can represent with the this symbol beta negative, or you can represent with this symbol, that is the electron negative. So these are the same way you can represent anyone, but here I am just using this one just to have the more clarity, the difference between the electron, because we are discussing the nuclear chemistry. So the question is, what is the nuclide, what is the parent nuclide, because this is the daughter and the neutron is emitting. Now what would be the parent nuclide? So what is your answer over here? This is the correct. Atomic number must be 53, mass number 131. There will be no change in the mass number, because this is the neutron emission. Daughter is increases one atomic number, so the parent should be one atomic number less than as compared to the daughter. So again, there is no need to remember uh, the symbol of the element. You may write over here, this is the X or this is the Y. So I am only concerned you have picked up the idea, not, there is no need to memorize the symbol of the elements over here.